We're here in Monteverde, Costa Rica, and what makes this place special is that there is a unique ecosystem here called the tropical montane cloud forest.
It's a region that we think of as a cloud forest. It receives a lot of its precipitation throughout the year as cloud and fog, and the plants here have really adapted to using that cloud and fog water.
Because of the constant inundation of these clouds, the temperatures are mild, it's very moist. It really is the perfect conditions for this hyper-diverse and hyper-endemic ecosystem to form and be maintained.
The word epiphyte is a very good descriptor. Epi means on and phyte means plant, so they're plants on top of other plants. Epiphytes are an incredibly important part of the plant biodiversity, particularly up in the canopy.
Ver las epífitas, la flor, toda una biodiversidad que hay en los árboles es completamente hermoso, ¿verdad?
I think of the epiphytes as part of the fabric of the entire ecosystem. If you remove the epiphytes, you're unweaving the fabric.
So climate change is causing changes in precipitation patterns. And then in addition, we have an increasing or a lifting of the cloud base height. So the elevation on the mountain where the cloud is condensing is higher up. And so the plants that used to be enshrouded in mist no longer are.
So the cloud zone is getting compressed, and consequently it's much drier and warmer in the lower elevations than it's ever been before. And these plants, of course, are tropical plants. They require a heck of a lot of water. And as we lift the cloud bases, we put the plants in a stressful situation that they really have not experienced before.
With rising cloud base heights and higher temperatures, these epiphytes were going to lose their abundance. And so for us, this really helped ask the question, well, what happens if we completely lose epiphyte abundance? How does that alter the microclimate and then the host tree health?
As it rains, the canopy is capturing so much of the moisture, and then it's regulating it. Instead of it coming down all at once and then washing the soil away, it's coming through at a much slower rate, in a rate that the ground can then absorb. So we really need this regulating structure so that the soil just doesn't keep getting washed away.
Yeah, I mean, people, I think sometimes might think that I'm an adrenaline seeker, but I'm really not. No, for me, really, it's about being able to explore aspects of nature that not everybody gets to see. And then it's kind of like a Stairmaster on a rope for 100 feet.
Sybil, she's a canopy monkey. She loves to get up there, climb around the trees, explore the canopy.
She took on the tremendous work of stripping whole trees of epiphytes and then putting sensors in them, maintaining them.
My role here on the ground is running the field crew and working through any of the measurements that have to do with the individual tree itself. They need to be adjusted, yeah. So we have 20 trees in our system. 10 of them are in pastures and 10 of them are in forests. 5 of the pasture trees are stripped and 5 of the forest trees are stripped. And we have them in pairs. So here we have this pair. So this is what the trees in this area should look like, absolutely covered with mosses and vascular epiphytes. And what we've done is remove all of that biomass and all of that matter so that we are just working with this strip tree and trying to understand the difference in how water is moving through these two trees with the abundance of epiphytes and without, which is what we project will happen with climate change.
So my role has been to kind of bring in some innovation, the use of drones and a bunch of different sensors that we can put on the drone that are looking down on the forest. It flies over the canopies and it obtains a bunch of really interesting information to tell us about what the health of the forest is, the epiphytes, the canopy trees, etc. Really, I love to say it this way, is to do physiology from space.
We've been working on building a model where we can use equations to explain how the presence of epiphytes or loss of epiphytes affects host trees and their surroundings.
Lauren has built a model that has all these knobs on it that allows us to dial back the epiphytes, dial up the cloud water, et cetera, to really look at how to make forecasts as to what is going to happen when climate change hits the tropical montane cloud forest region.
I feel like I've developed more of an intimate relationship with these plants, and we thought a lot about what to do with those plants, and so we set up a shade house where we can deposit the epiphytes that were in good shape, and we're using those for experiments on epiphytes. So we've done as best we could to try and save as many of them as possible.
And epiphytes are beautiful here. You know, people love them, people come here to see them, and it's very kind of the landowners that we're working with, that they could understand the importance of this research to let us do these destructive experiments on their trees, because they understood that what we'll learn could really help them understand how climate change is going to affect this ecosystem that they love.
This is very unhappy. So this is another one of these Cavendicias, but these are probably going to start to drop leaves. I mean, I was really surprised today, climbing in Terra Viva, which is right on the Continental Divide, and it's a very wet spot. It hasn't rained for about a week. We haven't really gotten a good soaking rain, and there were plants up there that did not look healthy. I definitely feel grief. I mean, it is something I think about all the time, that I'm studying a system that is, if not going to change in my lifetime, then the next generation's lifetime. I am very much affected by that. It really forces me to think about ways that we can contribute to solutions. Are there ways that we can evaluate reforestation projects that are on slopes, that are mixed species, that are from the lower parts of the region or from the higher parts of the region, so we can think about what are ways to restore some of those water resources that we think are going to be lost with climate change.
We've worked with at least 300 landowners. There's a huge willingness to reforest here. People want to do it. As of last year, we have given away 279,000 trees, all native species belonging to their right ranges. This year we have 21,000 trees, so we're going to reach the 300,000 tree mark. Within 22 years, we have a forest. We have a forest that doesn't just have the trees that we planted. It has all sorts of other tree species coming in and growing alongside of it. It's really hopeful as these forests come back fast, and they come back with all of these integral components that we didn't put in there, but basically nature just does the work after. That is our hope.